is very much on the right tool for the job rather than the tool at hand. And it's also where I'd say the conference where we believe that learning and understanding the history of computer science will help us solve the challenges and problems we face today. Because as we've said quite a few times, something which has not been invented at least 2 or 3 times is probably not worth invented. The first time we went in and did CodeMesh was in 2012, and we started it mainly out of frustration that non-mainstream programming languages were not getting enough visibility at mainstream conferences. I think it was all very much about Java, C++, Python, Ruby, and whatever was in the top 10 of the TOB index, and or Agile. And so, we almost went out with a slogan that, if it's Agile, if you're in for Agile, you're in the wrong conference. And we really went in and hit the ground running. I think the first year we had, for the first time ever on stage together, all 3 airline co-inventors, so Joe Armstrong, Mike Williams, and Robert Verding, interacting and talking to each other. We had Simon Peyton Jones, John Hughes, and Phil Wadler on the same stage, all kind of sharing the lessons learned from Haskell. Rich Hickey, had another keynote that year, and he spoke about the language of the system. What he had learned from the other keynote speakers who, whilst he was creating and working on Clojure. I think fast forward a few years, we had Bruce Tate. And he was moderating a panel, I believe, with Sir Tony Hoare. And one of the questions he asked out there was, how many of you have actually invented a programming language? And I'd say about 20 people raised their hand. So at the time, it was around 5% of the audience. And I'd add quite a few of them were actually not speakers. They were all attendees who might have spoken in the previous years. They'd come back, to share and to share, learn, and inspire others. So I've got a few slides just to come in and introduce the presentation, the conference this year. Let me go in, and if I'm allowed to share the screen. Yep, here it is. Perfect. So I'll go in very briefly and walk you through, I think, some of the highlights from this year. It's 2 days of programming language discussions. We've got over 40 speakers in all in 2 time zones, 3 parallel tracks, and so we took the opportunity this year in that Strange Loop wasn't happening. CodeMesh has often been called the European Strange Loop to actually give a fix to all of the Strange Loop junkies back in the Americas, and allow them to meet like-minded people online. So the first time zone on November 5th, we'll be focusing on European, African, and West Asian time zones. And the second day, we'll be focusing on American time zones, so both East and West Coast. So for once, someone attending a conference in California, all they need to do is get up at 8 a.m. and not later. But for everyone, all the core talks will be recorded and available after the conference. So you're still able to interact with speakers through the app after that. Every year, I think we have everything. We've grouped the talks together in 5 different themes, and these themes are very much, I think, related to each other. The first is kind of focusing around non-mainstream programming languages. So initially, I think there was a lot of functional programming, but we've gone beyond that. And more than kind of the non-mainstream programming language, I think it's some of the constructs and techniques and approaches in these languages, which then give us to a concurrency model. Often it's a no-shared memory concurrency model, which paired together with multicore gives us parallelism. Once we've got multi-core and parallelism, we've got scalability, and we've got scalability, which is both vertical as well as horizontal, as well as reliability. And by default, as soon as we've got scalability and reliability, we also have a distributed system because we need two of everything. And finally, that's all grouped together in infrastructure. And finally, with the belief that I think we've, a lot of the problems have already been solved, but we're just not aware of them. So, to avoid kind of going in and reinventing the wheel, but reinventing it square, I think, we look also a lot at the history and the philosophy of computer science, inviting a lot of the luminaries, a lot of the people who have helped set the foundation to where we are today. And, we've got 4 amazing keynotes. We always kind of, give space to kind of the younger rising stars, but as well as, finding out the luminaries, finding out those who we believe need to be honored in some shape or form. So, the opening keynote, which will hopefully set the whole tone, to the conference, is Thomas Petricek. He'll be talking about the cultures of programming. An amazing paper. I really recommend you go out and read it ahead of the conference. We're really proud to have Cynthia Solomon. Cynthia, has worked with a lot of really well-known names, and I think she helped lay the foundations to artificial intelligence as we know it today, and is also kind of the co-creator of the Logo programming language, so the language for children. And what she'll be keynoting on is One Computer Culture for Children. And this follows on to last year's theme, where we had Simon Peyton-Jones talk about how they're integrating kind of computer science in the regular curriculum. So you don't have computer classes. They're actually integrating concepts and ideas from computer science in regular classes. And indeed, there'd also be an Ask Me Anything session with Simon Peyton-Jones and Cynthia Solomon, looking at programming and how you teach programming for children. We've got Eric Mayer, who's got a keynote which is inside every calculus is a little algebra waiting to get out. So very much focus on kind of the whole concept that a lot of what we do is based on maths and logic. And we've got Feline Hermans, who will be leading a panel on type systems. So she will be talking, we've got, she'll be looking at, what, and I think, we're seeing a trend, with type systems around gradual typing, around session types, as well as, the never-ending debate on, strong versus weak typing, static versus dynamic typing. So there'll be a lot of interesting, names, joining us for it. One of them is Martin Odersky. He's on the panel. Other great names, to think about is, Leslie Lamport. He's got an Ask Me Anything session on, thinking beyond the code. So how do you actually think and reason mathematically beyond the code base? We've got David Turner, who is the designer of the St. Static language, and Miranda. And actually at CodeMesh last year, he went in and open sourced Miranda, which, and he was getting help from other conference attendees on putting it up on GitHub, and he will tell us about this journey. Martin Odersky is another one. Satnam Singh is a speaker we've been trying to get for many, many years. So many others, Kevin Henney, Elizabeth Ramirez, you might recognize, Jonas Bonner, the creator of Akka, Edwin Beredi, the creator of Idris, or Sergey Baikov, who you might know from the Orleans concurrency framework at Microsoft. So these are just some of the names which I wanted to drop. We've got a few tutorials which are still available. So one is functional software architecture, taught by Michael Sprevener. Introduction to TLA+, taught by Annette. She's with us tonight. If you want to learn Haskell, directly from the source or directly from the horse's mouth and hear all of the insiders about it, Haskell from Zero to Hero, which is taught by John Hughes, or highlights and insights in distributed programming, taught by Peter Van Roy. Peter, I think, is one of the leading forces behind CRDTs. I myself am teaching a course on architecting reactive systems. So it's based on my lessons learned in the Erlang ecosystem, but these lessons go way beyond that, and they can be applied actually to any other programming language. So these are some of the tutorials which are available. And I think what I'd like to do now is go in and introduce some of the speakers we've got with us tonight, and have a little bit of a kind of Q&A and a discussion with them. You might have questions yourself. And if you do, I would kind of recommend just go in and add them, add them to the chat. Okay, so the first speaker, I'd like you all to meet today is Laura Bocchi. Laura, thank you so much for joining us. Would you like to introduce yourself very briefly? Yeah.
Oh, yes. Hi, I am Laura. I am a senior lecturer at Kent. I'm working on quite theoretical subjects. I'm working on concurrency theory, behavioral types, which are types not for data, but for behavior, for communicating processes, so that we can then check that communications go as we wish. And yes, it's my second time at developer-oriented conference, but it's my first time at CodeMesh, and quite excited.
We're very excited to have you. Thank you for coming. Now, let me start with the first. Imagine you were in a black London cab, heading towards the ILEC conference center where we usually have the conference, to give the talk in person. How would you explain to the taxi driver, what you're going to talk about?
Okay. So first of all, the title of my talk is a bit misleading. I was thinking of talking about time constraint, but I've not been doing much this last year on that, so I thought about saying something different. In the last week, we did some progress in new work. Basically, I would say when you want to develop programs that are interactive, that send and receive messages, right? Often the description, the specifications of these programs, they describe very well what actions you can do, say with an API, but not very well what is the causality of interactions that are expected, or at least not in a very systematic way. Often this is done in English. So I will be talking about models of behavior that describe, say, how to behave with an interactive program. And I will give a bit of a hint on the theory. So I will show that not all models are good. There are bad models. We'll give a bit of a hint of the challenges of building interactive programs, especially when communication is asynchronous, when messages get sent and then get received afterwards. And I will talk about engineering behavior, building protocols, complex protocols out of more simple ones. Say you want to do banking with authentication, how do you put them together in a nice interleaved behavior? So this is what I will be talking about.
So it sounds, I think kind of the technical term is very much session types, is that correct?
Yes, yes.
And this is part of kind of also a much larger research project, which you've just been awarded a grant for. And I believe I think we're involved, but it's also where Lightbend is involved, looking at bringing. So it would almost like make it, what we were doing is we would what you would be doing would be allowing concurrent programming languages to communicate with each other in a much easier way, going beyond language barriers. Is that correct?
Yes, yes. So the idea is having a theory for structuring your interactions properly. The idea is that every participant can be implemented by using different languages, and yeah, this can be what I'm talking about can be easily supported by, say, the web infrastructure. And
exactly,
yeah,
yes.
This project is really good. So I recently hired the research associate for the project. So this is why we could do a bit more progress on in the last time. So I can show something new.
And I think, if we look at CodeMesh, often it's very much been, the industry meets academia. So I think a lot of these ideas in very early stage are then checked with the early adopters, and and often find a way. What would you say would be the biggest kind of industrial usage of what you're working on? And I think this is the main question everyone asks at the PhD defense thesis, I think, at least, alongside with the taxi driver question, but that's more,
So I in a way I'd like to find out by being here. It all started as a very theoretical work, and then we thought it could be very nice by taking this theoretical work and by using the OTP finite state machine of Erlang. We found it could be really nice. It could be a very nice way to tidy up, to have a stub generation out of formal models that allow you to keep your code tidy. And so maybe the first feedback maybe from Erlang practitioners, but I think I'm really open, because we are just exploring concrete applications of this theoretical work about composing protocols.
Yeah, I mean, what really excites me the most about it is the ability, for concurrent languages to go and interact with other concurrent languages. And by default, I believe with what you're doing is, once you've solved the concurrency problem and interaction across actors, you by default have distribution. So I think, by adding language transparency, I think, and that's really, I think, where we're heading, focusing more on programming models and paradigms more than just programming languages and approaches in programming languages. I think that's really where everything will start falling in place.
I see that a comment, the taxi driver is still confused. Now I've already forgot what I was talking about to the taxi driver.
No, that's Dmitry who's commenting, yes. No, I've had taxi drivers who had actually heard of Erlang, and so it was really,
Oh, the second part was not meant for the taxi driver, actually. It was already...
Yeah. So we got one question, which is, are session types interesting in Elixir as well? I think we're seeing a huge influx into the whole Erlang ecosystem with, we've worked, thanks to Phoenix, the kind of web framework, and which again I think uses a lot of the concepts and ideas behind Erlang, but packages them in a way in which focuses on adoption and ease of use. So I don't know if you've had interaction or have looked at Elixir.
No.
As a language, no. But I can answer that, and the answer is yes. I think session types are very interesting to Elixir too. But I think again, it's very and it's more about the interaction, I think, with Elixir also in other programming languages as well. Okay. Are there any talks you're particularly looking forward to at CodeMesh?
I had a look, and I wouldn't know what to say. I saw a lot of very interesting talks. So I think whenever I have time out of my normal schedule, I'll just look and jump into wherever I see concurrency distribution, or even something unexpected, just to learn something new.
What's interesting, I think I've also seen this with from physical conferences, in-person conferences. You go there, you spend a day there, you go from room to room, and you spend a lot of time in hallway tracks. When it comes to virtual conferences, it's you don't sit in and listen to talks full time. I think I've seen this behavior. You out of maybe 6, 7 talks in a day, people maybe attend 4, 3 or 4, and then maybe go back to other recorded ones later, and then continue with interactions through the app. So yeah, all right. And one question, if you had one question to ask, Leslie Lamport, what would that question be? And I'm cheating here because Annette and I will be interviewing him, so we're looking for interesting questions, from
I'll
from
think
other
about
speakers.
and type it.
Yes. Okay. Please do so. Perfect. Okay. Great. Listen, thank you so much again for being with us this evening, and we're really looking forward to learning more about your work. Okay, so I think then we've got 2 other speakers with us today. I think they work in very different ecosystems, but I think a lot of the work they're doing is in a way related, and I think there is an overlap, and I think there's a lot which both communities have to learn from each other. And one of the speakers is Dmitry Lvotchenko. He's a senior developer at Airline Solutions. And he's also kind of the key implementer of several virtual machines which target the Beam bytecode, implemented in both Rust and C++. And together with him is Ron Presler. So Dima is based in Stockholm. Ron Presler, he's based in London. He works with the Java Platform Group, where he's the technical lead for OpenJDK's project Loom. So what they're doing is looking at adding user mode threads and tail recursion to the JDK. So Dima, why don't you very briefly introduce yourself, and then Ron, over to you as well.
Yeah. Hello. So my name is Dmitry Lvotchenko, and I work in Airline Solutions in Stockholm, but the main topic of my personal interest, which coincides with my work as well, that's designing a new generation, let's say, of virtual machines, like improving on what Beam is, and experimenting with it, looking for potential markets who would be interested in such things. So my project's open. The implementation of Beam is not secret anymore. It's better documented now. There are multiple projects making it more clear. And my talk will be explaining what is Beam to the public who seen very little of it or never seen it before, or people who are familiar with other virtual machines. So I would be explaining how it is better and what it offers to the personal user or to an industry user. So things like scalability and transparent distribution, they offer nice things to an industry user. So that will be my talk.
Okay, Ron, why don't you quickly introduce yourself and give us a quick highlight on your talk. Yeah, thank you for being here tonight.
So I'm Ron. I work on OpenJDK at Oracle. OpenJDK is the main Java implementation these days. It's done primarily by Oracle, but there are other contributors as well. And I am the technical lead for Project Loom, which aims to ultimately add user mode threads to Java, to the Java ecosystem. By the way, when I say Java, I don't mean necessarily programming language, but the entire platform, what some people call the JVM, but they usually mean something much greater than that. The talk I'll be giving is about why we've chosen to address concurrency in the way that we have, which is actually similar to how Go and Erlang, maybe Scheme do it, but is quite different to how, say, C# and JavaScript and Rust and C++ do it. So they use something called async await. We've decided to do user mode threads.
Now, going back, to the very first kind of Java white paper I read back in 1995, I seem to recall that there were lightweight threads. I believe they were called lightweight threads at the time. Do you know why they were removed, from the original JVM? It was a long time ago, so
removed I don't know, 24 years ago.
Exactly.
From what I know, so first of all, one of the big differences between what we're doing now and what we had then is that back then the user mode threads they had were all scheduled on top of a single platform thread, a single native thread. So they didn't actually support multiple cores.
No.
And as a result, the throughput that they got from them was quite lower from what they could get by just using native threads. I think the story was a bit more complicated because that was before, that was for a very short period of time. It had some of it was just historical circumstances. That was the first VM when it was just an interpreter. But when Java was designed, they knew it was designed to be compiled, and then when the new VM based on a compiler was built, which exists to this day, it's called Hotspot, it just didn't support that.
Okay.
Various reasons. I'm not entirely privy to exactly all the details of what happened and why.
No, thanks for that. At least me wearing my Erlang hat, we tend to go in and design our programs irrespective of the underlying hardware, and we tend to design them in a concurrent way. But look at large scale concurrency. So and I do recall. I think it was when I did read the white paper. I think it was 1994, 1995. It was, oh wow, no memory handling, a garbage collector, a language which compiles to bytecode. I know at the time we were being called crazy, for wanting to implement scalable telecom systems, which had to be resilient on a program with a programming language which compiled to bytecode, and then Java came along, and it was just like, okay, yes, we're not alone. It felt good to know that, and it felt good to actually have a response to those saying, oh, you need to do it in C++, C and C++, they're the only way. This is, I believe, Ron, this is your second time you're speaking at Code Mesh.
Yes, I think the first time was 2 years ago, and it was about a completely different topic, about the history of logic, formal logic.
Exactly, yes. Which again, though, is it's a different topic, but I think it's very much also in theme with the conference itself. Now, one of the questions I think Dima and Ron, for both of you, I mean, do you see where should our users be using the JVM versus using the Beam? Do you see kind of separations and right now where one is better than the other? And the second question is, what Dima, what have you learned from the JVM, and Ron, what have you possibly learned from the Beam, from the Beam and the Erlang approach to doing things?
So now Beam is one step closer to JVM.
Yeah.
Because we have JIT introduced, and that totally improves the performance. So now the line is getting blurry. There is no clear line. What would you want to use if you're starting a new project? So learning from JVM, there have been millions of dollars invested into making it fast, blazing fast. And there have been, I'm not sure, but quite a good money invested into making Beam good at what it does. And now they're getting closer. So I would be interested to learn and even contribute myself to make this line disappear, to make this two projects coexist and make code from one run in another, like Java something for Beam or Erlang something for JVM. So this kind of interaction, if you bring Beam to an industry, to a company, and you say this is the good technology you wanted, and they will say, hey, we have a legacy Java system, how would we migrate? So if you can offer a solution to migrate piece by piece, like gradually, they would be willing to give it a try. If you say this technology is new and you have to throw away everything, they will never adopt it.
Yeah, I think, okay, interesting.
So,
I believe that by now it's been over $1 billion, probably with a B, invested in Java.
So if you compare
versus one person, you're working on the JIT compiler for the Beam now for maybe 3 years. Yeah, that's. But yes, indeed,
yeah. So there are stories of migrating C projects to C++, and there are stories of migrating C projects to Rust, and there are large software projects that succeeded in doing so, and they only could do this by slowly. The right word is for Rust is oxidizing, module by module. So that's how you do it. You never transition to a new technology in one go. So so how would I compare? They have Java has a long history, has a long list of projects written in it. It's successful. It's running in big systems. So was Beam. I would love to contribute to merging them together and make it easy to hop left and right between them.
Yeah. Ron, I have one question. You're saying, I mean, you're obviously looking at the whole ecosystem as a whole. Is the work you're doing, are you seeing it more? Are you thinking of having something which is actually will allow you to actually make it easier to create new languages, or to run on the JVM? Or are you thinking in terms of allowing existing languages to be much more efficient?
I'm not thinking in terms of languages. Languages are not a big interest of mine. I'm more interested in software systems and algorithms. So I don't care which language you use. Although I think that Project Loom will make it much easier to implement something like Erlang in the JVM for those who prefer writing their code in Erlang. But it's independent of the language you pick. The goal is to make it easier to write applications, usually servers, that service a great number of users at the same time. And when I say writing, so code is just this, writing code and even reading code is not all we do when we write software. Much of the work and one of the things that set Java apart, and also Erlang, I think, is its observability. And when you support something new, when you add something new to Java, it's a whole, it's not just a matter of how to express things in language, but how to export them to debuggers, how to export them to profilers. And those are things that are just as important as the ergonomics of code.
Yes, I think, I agreed. Okay, now the questions, are there any particular talks, Dima and Ron, you're actually looking forward to at CodeMesh, or any particular Ask Me Anything sessions or panels? Yeah.
There are two things which genuinely interest me. One is to bring order to software projects, that's anything related to types or to making more mathematical structure to software, because usually it's chaotic and made in place following the requirements list, which constantly changes. So the code base constantly keeps rotting and becoming obsolete. So anything to fight this, I would love to hear that, or related to this topic. And the second thing, I would just scroll again through all the topics, looking for it. That's making machine control. Again, related to bringing order. So making machine control me working on the project. I'm not always focused, and so is no one else. People getting distractions, people getting real life questions to solve, and they return to project, they make mistakes. So if machine will help me to stay productive and do fewer mistakes, so anything to enforce quality of my code, I would love to see that. So there was at least there were a couple of talks that I noticed. If I will scroll through them again, yeah.
Absolutely, and hopefully, I think, they will also be there to actually challenge you and make your head hurt. I think that's how we described the very first code mesh, where it was information. Yeah, we learned so much. It was amazing. It was fantastic. Yeah, Ron, what about you?
So two talks that caught my eye in particular.
Yeah,
Herbert's talk about mainframes, because I know very little about them. And the other is a talk about inductive program synthesis. And that is closer to something that interests me, various formal methods. And I'm particularly interested in it because it is inductive rather than deductive. And that is, I've grown a bit skeptical of various deductive methods. So I'm interested to see what that's all about.
Okay, excellent. And one question: if you had a question to ask Leslie Lamport, what would that question be? Focusing on the theme of his Ask Me Anything session, which is kind of thinking mathematically beyond the code.
Right. So I've been working with TLA Plus quite heavily for a few years, but one of the things that's hard to teach beginners. Perhaps I think that's the hardest thing to teach beginners when it comes to TLA Plus, is how to think of the program at the right level. And what I would like to ask him, because the whole idea, if you try to describe your program the same way as the code, then you're kind of missing the point. So I would like to ask him if he has any tips for beginners on how to think and describe your program at a higher level, how to focus on the salient details and abstract away the irrelevant bits. So how to pick what's relevant and more relevant and less relevant for the questions I want answered.
Interesting. Okay. This kind of reminds me, and I think, and that's what, Annette and I will be interviewing him, but I remember, when I was studying computer science, the lecturer came in and he waved the book. Oh, this is the program machine semantics course. You have it takes about 40 pages of proof to show that one page of 48 pages of proof to show that one A4 page of code is correct, which means it's a great thing to know about, but it's completely useless and you won't be using it in practice, but you need to know it anyhow. And I suspect your whole notions of abstraction is how can we start pruning the tree, to actually pruning the search tree to focus on what we actually want to prove is correct versus areas which we know most likely will be correct or where we'll pick up errors. Am I understanding your question right?
Well, one of the things, so Leslie Lamport looks at systems more like how a physicist would look at a system rather than how an engineer would. So it's about looking at it from the outside. And if you want to model, say, the solar system and know where all the planets are going to be, a physicist would represent them as point masses rather than trying to build each and every planet. And that is hard, I think. That's the hardest thing for programmers to learn when it comes to TLA+. So I'd like to ask him for tips for beginners, how to not think about problems like a programmer, but how to think of them as a physicist. Just focusing on some details and knowing what not to focus about, regardless of verification, regardless of how you want to prove the correctness, etc. Just describing things at a high level.
Excellent. Okay. Thank you so much. I think, yeah, I wish George Armstrong and Les Lamport, would have had the opportunity to meet each other. I think they really would have gone on like a house on fire. Is there anything you would like to add? Else, I'll pass over to our next speaker, Annette. Any Dima, Ron? So thank you very much for joining us this evening. And yeah, I really hope, we're very close to each other, so I really hope we'll soon be able to meet in person as well. So we've got Annette Benyusa, so she's a senior researcher at the University of Kaiserslautern in Germany. And I think I've been working with Annette for many years on a variety of projects focused around distributed systems, focusing around data consistency. Synchronization, replication, and other odds and ends. So Annette is actually not speaking this year, but she is teaching the TLA Plus tutorial, and has attended CodeMesh in the past year for many years. So, and thank you very much for joining us. Why don't you introduce yourself? I think it's more better that it comes from your own words and mine.
Yeah, so thank you, Francesco. As you mentioned, we've been together on quite some projects related to distributed systems, CRDTs, data storage, databases, and there were quite some successful European projects involved, where also one of the other persons giving a tutorial, Peter van Roy, was leading one of the latest projects, Lightcone, and the Syncfree project, where we also did a lot of Erlang programming, and it was always a pleasure working together with you. Besides all the research work, I'm also lecturing at the university, and there I had a pleasure actually to introduce TLA Plus to some of my students in the class, and I learned a lot from the way that the students learned about it, and I'm forward to enlarge the user base and knowledge base of people who want to do things TLA Plus. And of course, I mean, I agreed giving the tutorial before I knew that Leslie Lamport would also be joining the whole thing, so yeah. That, right?
It's well, we'd been hoping on having him for a long time, and I do admit I didn't tell you we were in conversation with him about joining when we asked you to give the tutorial. But that said, I think Leslie Lamport will probably be the easiest person to introduce at the conference, because his work has been referenced and talked about at pretty much every single CodeMesh since the first event in 2012. So could you let me ask a little bit about CodeMesh. What does, you've been at CodeMesh, quite a few times. What is CodeMesh for you as a conference? And again, it's a conference where the industry meets academia. What has, could you tell us a little bit about your experiences?
So for me, CodeMesh is quite interesting, because there's a lot of people that I know from various other locations and occasions, and it's always a little bit like coming home, right? So you have these kind of conferences or meetings where you meet people of the same spirit. Now, this does not necessarily mean that you don't have topics on which you disagree, but there is the spirit of being open for new ideas, of kind of taking new ideas and juggling with them, putting them into new context, and just trying to get a whole new view on the whole world of software development, programming languages, and fitting the different puzzle pieces together in a new way. That's kind of what, for me, CodeMesh is at its heart.
Exactly. Yeah. Thank you for that. Have you? I think I'm thinking of your students, and this is also a question I'll ask Herbert, but. I think a lot of the topics covered are topics which are also of interest, I think, to your students, but probably go beyond kind of the lecture room and make it more cutting edge. What is it you've actually learned from CodeMesh, which you've then brought back and taught your students? Mm-hmm. Is that That's
definitely the case. I mean, there is so much material out there on a lot of different topics, but you need to select the right ones and also identify interesting trends. And there are quite a few trend setters or trend establishers at CodeMesh that show the path into where the future might actually lead us. And for me, it's a very valuable resource for keeping up to date, getting also to talk to people. It's very familiar in a family style when you meet, because you can simply go to people, ask questions. There are all these panels where interaction and discussion is really encouraged, and I hope we are also able to move this experience to the online version that we'll have this year. But I'm very positive on that, because I know that many of the people who will be there will still be engaged and will try to, or will be able also to keep discussions up.
So our real focus is, and then from day one, when we basically made the decision, to run the conference virtually, was look at the whole social interaction, look at the whole hallway track, and trying to understand how can we best reproduce it. And I think one of the areas is using the Wove app, where anyone can go in and start forums and create discussion groups about particular topics. That's has in past conferences worked really, really well. We have a lot of kind of Ask Me Anything sessions where users, where conference attendees and other speakers can go in and ask questions about different themes. So we've got an Ask Me Anything session with Martin Odersky, where we can ask him anything on Scala. We've got one around, with the airline co-inventors. So it's Mike Williams, Robert Verding, and their former boss, Bjarne Decker, who founded the computer science laboratory. We've got Ask Me Anything sessions with Cynthia Foss-Solomon and Simon Peyton-Jones on teaching children to program. We've got one on orchestration and containerization. We've got one on machine learning and AI. We've got one there's plenty for all tastes, and then alongside that, every talk is half an hour plus 10 minutes of Q&A, and again 10 minutes of Q&A to create have the questions, the follow-up questions, and continue the discussion beyond a kind of a point to multi-point means of communication. Attendees will be able to unmute themselves and ask questions. We also have other speakers going in and introducing speakers. And this is both former speakers and current speakers, about introducing people about topics they're passionate about. So that will hopefully help as well. Bringing it, and we've got Birds of a Feather afterwards, where in virtual rooms, people with certain interests can connect. We've got lightning talks. So hopefully, and also through the app you can contact everyone privately as well, and spin off a meeting room, and have a one-on-one chat with them. So hopefully, I really hope, we'll be able to recreate at least some of the vibes and some of the buzz we had, including speakers standing in the front row, jumping up and down, being able to hold their excitement.
So of course also the great team that is behind the whole organization. So I remember another conference that was running in summer, where I actually attended with a group of students, and it was very nice to see what kind of interesting ideas they came up with, like where we're actually able to see a bit more of people, not just name on the conference badge, but see a bit of how life is going, right? Even if we're spread over all different places, some things are very similar, and it's just nice to have a bit more interaction.
Also, you and I think have have the task. I was going to use the word daunting, but it's probably not daunting. I think it's a challenging task. I think I'm actually going and interviewing Leslie Lamport. Is there anything in particular you would like to ask him?
Yeah, well, I must say, recently I started digging a bit more into TLA Plus again, in particular the theory improving part, and there are a lot of interesting aspects that I didn't realize the first time I was looking at it, and I would like to learn from him a bit more about the reasons why he set up the system the way it is now working, because I think there are some very interesting design decisions made that might seem strange for first-time approaching people, but tend to have some very nice side effects for longer-term users. Like the way you structure proofs, for example, seems to be a bit different from other theorem improvers like Cork, like Isabel, and so on. Still looks familiar, but yeah, just a bit different. And knowing the way that Leslie Lamport thinks about these things, having this particular goal in mind, making mathematics more used and more usable within computer science, I would like to learn more about his ideas behind that.
Excellent. Okay. Thank you for that. And yes, and yeah, really, really looking forward to it. Is there any talks you're particularly excited or interested in?
I have a few talks. So the question came up now. I was able to prepare a bit, and so they're like out of these many talks, there are really there is like a wonderful selection of talks. There are three talks I'm particularly looking forward to. One is the talk by Satnam Singh. So he was actually one of the reviewers for my thesis, and I have not seen him in a long while. I'm really looking forward to where his work on verification and hardware and FPGAs and so on brought him over the last couple of years. I'm also looking forward to the talk by Victoria Furdish about security of the beam. So security is often a topic that we try to avoid because it's difficult. And I think Vicky has some cool ideas of how to make this more approachable for programmers who typically want to refrain from it. And the last talk that I would like to highlight here is the one by Philippa Gardner. So Philippa was actually the last person I met on a conference travel in February, just before all the cloning and so on happened. And yeah, I'm looking forward to her work on Julian, this multi-language platform for compositional symbolic analysis, and yeah, the work she's been doing on JavaScript in that area too.
Great. Yeah, I have to say I've been asking Satnam Singh now for maybe 4 years to come at CodeMesh, because I know he would really fit in perfectly and find himself alongside really like-minded people. But and this is the first year actually where everything he's doing is completely open source and completely in the open, and it's not a super secret project. So I think as soon as that happened, he basically said yes, absolutely, and he was ready to come to London actually to speak in person. So yeah, all right. Excellent. Listen, thank you so much for being with us tonight, and we are really looking forward to having you at the conference as well. Yeah, thank you, Annette. Herbert, hi there. Saving the best for last. So finally, I think we've got Herbert Daly. So he's a senior lecturer at the School of Mathematics and Computer Science in Wolverhampton, and he is Herbert is also a huge Erlang and Elixir fan. I think he joined the Erlang meetup back in 2005, if I remember correctly, and I think that's when I first met you, if I recall correctly, right? 2005, 2006. It was a long time ago. You were taking your master's at Oxford University at the time, which is the same program now teach at. So when we first started speaking about about kind of your later interest, mainframes. I was very, very surprised. So why don't you first introduce yourself? And then we can talk about a little bit about your talk. Yeah.
Okay. Hello. My name is Herb Daly. I'm a senior lecturer at the University of Wolverhampton. I've been a long time Erlang and Elixir enthusiast and a lurker. And so this is the first year I'm speaking, but I've been to pretty much all of them, kind of going way back. I was thinking, we were talking the other day about some of the people that I met at the Erlang Exchange. So that would have been, kind of late 2000.
2008. It was right when the financial markets were crashing around us, and we were there, playing with the violin in the middle of the city.
Crying into our beer. So I have a long-term interest in the community. I started out same as you as a young software engineer in telecoms, and as time has gone by, I've inched my way closer and closer to academia, to the extent that I'm now kind of inside there, and I'm a little bit of a kind of a joint in a seesaw. So I have an academics kind of interest in kind of industry stuff, and an industry person's interest in academia, and at the same time I have an interest in education. So helping the new ideas get out there and helping the new people get their hands on the new ideas.
Interesting. And what got you into mainframes? Because it was, I think this sounds great, but and I'm leading on to the kind of the conversation we then had the first time, when you told me about it. But
to be honest, it's as an academic, I kind of deal with many different worlds, and Beam is one world that I love and am fond of, and for various reasons, I ended up getting to know the mainframe community really well. The insider story of that goes, I was chairing something called UKCMG, which is the Performance and Capacity Professionals user group, so performance and capacity. And you see how this ties in with Beam and its derivatives. This is where people think about performance. This is kind of what happens when this stuff goes out into the wild. And so there'd always been a mainframe track, partly because performance, licenses are charged based on how much they're used. And so there are people who spend a lot of time and money thinking about how to kind of spread loads, how to avoid kind of spikes and stuff like that. And while I was there, I listened to a talk on the mainframe track. And to be honest, mainframes reminded me very much of the type of switches that I started out programming and that you would probably know quite well. And they also said they were looking for a new generation of people to take up the challenges that the platform has. And being an academic, and I'd recently kind of got my first post, I thought, well, that could be an interesting challenge for some of my students. I mean, not for all of them, but definitely some of them. That would be something interesting to do. And so over time, I've developed these relationships, and I've watched how it's evolved over the last maybe 10 years or so, and it's been very interesting. Now, I'd often thought that these worlds should really get together because there are all sorts of things that they have in common. But curiously, every time I've had a go at it, they have very much resisted. So if I say to kind of mainframe world, which is very much kind of enterprise, some of it does kind of resist some of the open technologies, and they definitely don't see maybe the immediate benefit of some of the kind of highbrow tech that we talk about at CodeMesh. And likewise, when I talk to the alternative tech kind of CodeMesh people, they kind of go, mainframes, why would we do that? That's just such a bad idea. but they do have so much in common in terms of, like, you know, the underlying design and the world that we enjoy now, you know, this kind of cloud kind of oriented world, owes so much to ideas and technologies that mainframe people spun up in the first place and pioneered. There are some interesting trajectories in terms of how popular or how necessary both perspectives are becoming, and I see them as something that's converging. So it felt like the right time to out myself to both groups and just to see what happened. I do actually have to credit a friend of mine, Evadne Wu. Hello, if you're watching. Who I met at an Elixir event, and it was her who kind of gave me the shove this year, because for many years I've been coming along, I've been bringing a big group of students to try and, you know, kind of seed the ideas in their mind, but I've always kind of gone, you know, do I have enough to say on a topic that would be interesting to this group? And she kind of gave me a shove and said, no, go on, talk about mainframes, talk about this this thing that you've been avoiding bringing up. So so this is my first time as a speaker, but some of you might have met me before if you've been to previous events. Normally hiding behind a crowd of students.
Yeah, no, well, I mean, you were behind the stand last year at Wolverhampton, actually using my book to hold up the project. Oh no, so someone stole the, yeah, that's right. Someone stole the book, the airline book from your desk to hold up the projector in one of the rooms.
Yes. Up, yeah, holding up a projector.
Yes, yes. What did your students, you know, a lot of your students attended, you know, Code Mesh last year. What did they get out of it?
So they just got a little glimpse of what an exciting and interesting world tech can be, and that it doesn't have to be all, you know, kind of very, very standard, we know everything kind of technologies. I was watching a video the other night that just made me want to scream, which said, you know, oh, the top 10 dying languages. And I think Erlang was like number 5. And I go, what do you mean? That doesn't make any sense. So, yeah, you know, and there are so many people that kind of get their information from these very reductive.
It was so last year, Herbert. Come on.
Yeah. and don't kind of get a view on the energy and momentum that a lot of these technologies have behind them.
Exactly.
So, if anything, that was it. Just that they got a sense of the energy around this range of different technologies, because it's not just Beam stuff. There are different things that people are doing, and how they're solving some really interesting problems, and some of them take off hugely. Some of them take off hugely. So I've never had a student come along who's regretted coming. I think the very first time we took a stand, we had a couple of tickets, and they went to some of our more enthusiastic students who were they'd over time become a little bit, let's say, demoralized about you know, the potential of a degree to kind of deliver on their dreams. And we took them to Code Mesh, and I've got a picture of them with like 1,000 stickers on their laptop, standing talking to Joe Armstrong and Carl Hewitt, and just looking as pleased as punch. And then going back and telling all their mates about the amazing time they had. They went down to London. You know, they saw these different events. So I mean, I find it's often as important to give people a sense of how big and how interesting the world of tech can be, and definitely Code Mesh delivers on that.
Okay, thank you for your kind words. Yeah, I you know, just to add, yeah, it's I'm still hung up on this dying, tech. It's not about programming languages, it's about the ideas behind programming languages, and it's about how you move forward, the industry as a whole, and how we can all learn from each other. And
what you see, but that's the whole thing. You have to go to events like this to throw away those ideas.
Exactly. Yeah.
There's someone that's that they've got some methodology that they're using to figure out which languages are growing and which ones are dying, but clearly they're not actually understanding what's really going on.
Yeah. Exactly. Well, it depends also, what part of the world you're in, and if it's if you're working with kind of what's hype-driven development, where you pick the language which is hyped versus the right tool for the job, and we're very much about the right tool for the job versus the right the tool at hand.
Yeah, I mean the other thing that I've found in my experience is if you have interesting technologies, you always have interesting solutions to problems, or solutions to interesting problems. So I can always remember every time I used to drop round and see you and we'd have a chat, and you'd tell me something that Erlang Solutions was working on, and I go, oh wow, that's a really interesting project. I'm thinking about I remember you doing many years ago, there was a traceability thing that started out tracing halal chicken in Malaysia and ended up getting sold tracing pork sausages in Denmark. And this was at the time where these sorts of issues, traceability in the food, it wasn't stuff that people were talking about a lot. It wouldn't have come up on
I think we had to trace something like 300 million chickens per year or something like that, which you needed scalability, and you needed concurrency to deal with it.
Exactly. So it's always kind of fascinating kind of applications, and that kind of gets the blood moving a little bit if you're a youngster. Like I say, it makes you think about the things that are possible.
What are the talks you're most looking forward to?
So the one on the culture of programming, I'm definitely interested in, because that's kind of been a theme that I've seen, kind of different tech tribes and tech cultures, and how they kind of come up with some kind of interesting perspectives. I'm just glancing at the
we always kind of save I think one of the keynotes to someone who one of the kind of younger members of the community who deserves the space for the work they've been doing.
Something interesting.
And I'm actually proud to say we've had many kind of first-time keynote speakers who've then gone in and done a stellar career.
And I've met
on the conference circuit.
It's been great for my networking, kind of knowing some really kind of some people on a great trajectory. Looking forward to the talk on open source in Miranda, because there's I used Miranda long ago, and I met David last year. But also it kind of ties in with me mainframe theme, that there are some really interesting old ideas, and kind of bringing them together with some new ideas can actually create something kind of very special and interesting. So I'm looking forward to that one. Of course, I'm very interested to hear from Leslie Lamport, because I don't think he's been to Code Mesh before, and I remember
he's not. No.
Having a conversation saying, oh, one day maybe we'll get him. And 2020 has been bad for almost everything else, but thank goodness it's finally delivered.
Opportunities have come out of it, So what question would you ask Leslie Lamport?
So characteristically non-technical. So I did some work with TLA many years ago when I was an undergraduate, and it was trying to kind of solve kind of problems. I would like to know what he sees as the juicy fruit for TLA right now. So not the low-hanging fruit. So what are the things that we can that we can use it to solve or decide or fix. And maybe that's going to be something around, I don't know, self-driving cars or something like that that's really kind of current. But what are the things he looks forward to be able to saying, right, now we've nailed it. That's a problem. And once we deal with that, it's like a force multiplier. It's going to make a load of other things possible.
Excellent. Okay. So yeah, again, thank you very much, for being part of this. Thank you, Laura, Ron, Dmitry, Annette, again, for joining us tonight. And we all look forward to seeing you at CodeMesh. So, we'll be in touch, if you've registered and that you have a discount code, if you've not registered yet. And if not, see you all on Thursday. Have a great evening.
Thanks very much, everyone.
Thank you.
Bye.
Right.
Bye.